Imagine posing a genuinely tricky question to your digital assistant, something that requires a bit of nuanced reasoning. And then, imagine receiving a confident, articulate answer in return, an answer that sounds not only plausible, but also remarkably insightful. In today's world, we've almost come to expect this level of performance from our AI assistants. It's become commonplace. We often operate under the assumption that there's some form of genuine intelligence, a spark of understanding, driving the words and responses we receive. But a recent study conducted by Apple pulls back the curtain on this perception, revealing a different, perhaps more sobering reality. In their research, they put advanced AI models through a series of tests, presenting them with simple logic puzzles designed to assess their reasoning capabilities. These weren't complex, abstract problems, but rather the kind of straightforward tasks that a child could easily solve with a bit of thought. And the results? Well, they were quite revealing. It turns out that these AIs, despite their impressive linguistic skill and ability to generate coherent text, struggled significantly when it came to applying basic reasoning and problem-solving skills. Apple's experiment wasn't just an academic exercise confined to the lab. It carries significant implications for the real world. It serves as a wake-up call, highlighting the limitations of current AI technology and urging us to approach its integration with caution. As we continue to rapidly integrate AI into increasingly critical systems, from healthcare to autonomous vehicles and vital infrastructure, Apple's findings force us to reevaluate our level of trust in their ability to perform complex logical operations reliably. The study underscores the fact that beneath the seemingly intelligent surface, there are fundamental gaps in understanding. These models, despite their sophistication, can construct arguments and solutions that ultimately collapse under scrutiny. All it takes is a bit more complexity, a slightly more challenging scenario to expose their underlying weaknesses. This is a pivotal moment in our understanding of AI. It's a moment that forces us to critically rethink our assumptions about what AI can truly achieve and, perhaps more importantly, what it cannot. Reasoning for humans means thinking logically to reach conclusions. For AI, it's supposed to mean understanding rules and making deductions. Most AIs, like large language models, excel at pattern recognition, not true reasoning. They can generate poems or summarize articles, but struggle with tasks that require abstract thinking or understanding causality. Without real reasoning, AI can't be trusted for complex problem-solving, like diagnosing rare diseases or planning intricate tasks. Human reasoning blends logic, intuition, and experience. AI, built on statistics, approaches problems differently and often misses the mark. They don't inherently know that a block can't pass through a wall. They must infer it from data. When faced with unfamiliar problems, their logic often breaks down. Apple's study set out to pinpoint exactly where and why this happens. To test AI reasoning, Apple stripped away trivia and focused on logic puzzles in controlled digital sandboxes. The puzzles were simple: arrange colored blocks on a grid following specific rules. The AI had to read instructions, plan steps, and execute them. No partial credit, just right or wrong. Apple tested advanced reasoning models like Claude and DeepSeek, not just general chatbots. By increasing puzzle complexity, they measured exactly when and how the AI's reasoning failed. These models were supposed to be the best at logic, but the experiment was unforgiving. The process revealed whether the AI could truly translate rules into correct actions. If these top models struggled, it signaled a deeper problem in AI development. The results were clear-cut. Either the AI solved the puzzle, or it didn't. Apple's tests exposed a harsh truth. AI models handled simple puzzles, but their performance collapsed as complexity grew. They seemed to reason at first, but adding just a few more rules caused their success rates to plummet. Instead of true logic, they relied on pattern matching, which failed with novel or complex problems. A major issue was hallucinating constraints, making up rules or ignoring real ones. The AIs also struggled with planning ahead, often making moves that blocked future success. Unlike humans, they couldn't maintain a logical state across multiple steps. The study showed that current AI lacks robust, scalable reasoning. Their logical house of cards fell apart with just a bit more difficulty. Apple's experiment made these weaknesses undeniable. You might think specialized reasoning models would outperform general language models, but Apple's study found both hit the same wall. Reasoning models did better on easy tasks, but their advantage vanished as puzzles got harder. Both types ultimately failed when faced with more complex multi-step problems. The core issue: both are built to predict the next word, not to reason symbolically or verify plans. Specialized training helped a bit, but didn't solve the fundamental problem. These models are convincing actors, not true thinkers. The study revealed that fine-tuning for reasoning only delays failure. It doesn't prevent it. Both general and specialized models are limited by the same architecture. Apple's findings highlight a deep flaw in current AI design. The root of AI's failure, despite all the hype and progress, lies in how it learns. It's a fundamental issue that plagues even the most advanced systems. We often marvel at their ability to mimic human-like behavior, but beneath the surface, a critical difference exists. AI learns by finding statistical patterns in vast datasets, not by truly understanding concepts in the way a human does. It excels at identifying correlations and associations, but it often misses the underlying meaning and context. This reliance on pattern recognition is both its strength and its weakness. When faced with a new logic puzzle, something that requires genuine reasoning and problem-solving skills, the AI, instead of analyzing the problem from the ground up, searches for familiar patterns it has encountered in its training data. It's essentially trying to match the puzzle to something it has already seen, not by applying first principles or fundamental reasoning. It lacks the ability to break down the problem into its core components and solve it step by step. Unlike humans, AIs lack a symbolic reasoning engine. They don't possess the innate capacity for abstract thought and logical deduction that we take for granted. They struggle to manipulate abstract ideas like all X are Y, or to understand the implications of such statements in different contexts. This limitation severely restricts their ability to generalize and apply knowledge to new situations. Their memory, while vast, is also limited in crucial ways. They can't reliably track the state of a puzzle or remember past moves in a complex sequence of actions. This makes it difficult for them to maintain a coherent understanding of the problem and to make informed decisions. This leads to contradictions and forgotten rules, as the AI struggles to keep track of all the relevant information and constraints. This is especially problematic in multi-step tasks that require careful planning and execution. They also lack common sense and a world model. They don't have the intuitive understanding of how the world works that humans develop through experience. Basic concepts like object permanence, the understanding that objects continue to exist even when they are out of sight, or spatial relationships aren't built in. In Apple's synthetic world, a carefully designed testing ground for AI, these deficits became glaringly obvious, revealing the limitations of current AI technology. The AI's plans were often physically impossible, demonstrating a lack of understanding of basic physics and real-world constraints, or logically incoherent, revealing fundamental flaws in its reasoning processes. Their linguistic fluency, their ability to generate seemingly intelligent text, masked a profound lack of situational awareness and genuine understanding. The experiment forced AIs to confront problems that went beyond simple pattern recognition. They couldn't solve with language alone, exposing the limitations of relying solely on linguistic data. The gap between sounding smart, generating grammatically correct and seemingly relevant text, and actually reasoning about the world was laid bare, revealing the true state of AI's capabilities and highlighting the challenges that still lie ahead. AI's confident answers can be dangerously misleading. We tend to trust fluent, authoritative responses, assuming sound logic behind them. Apple's research warns that this confidence is often a facade. In medicine, a confident but flawed AI recommendation could mislead doctors. In finance, a model might trigger disastrous trades by mistaking correlation for causation. The real risk is automating judgment, letting AIs make decisions that require wisdom and context. Deploying models that mimic intelligence but lack reasoning could have serious consequences. Apple's findings urge caution before trusting AI with critical decisions. We must ensure the driver actually knows how to think. Exposing AI's limits is just the start. It's a crucial step in understanding what AI can and cannot do. We're beginning to see the boundaries of current AI technology, and that's incredibly valuable. The real challenge is overcoming them. It's about pushing the boundaries of what's possible and developing AI that's not just powerful, but also reliable and trustworthy. This requires innovative thinking and a willingness to explore new approaches. One promising path is neurosymbolic AI, a fascinating blend of two distinct approaches to artificial intelligence. Combining neural networks' pattern recognition, their ability to learn from vast amounts of data and identify complex patterns, with symbolic logic engines. These engines excel at reasoning and manipulating symbols according to predefined rules. This hybrid could interpret instructions, understanding the nuances of human language and translating them into actionable steps, and rigorously check logical steps, ensuring that the AI's reasoning process is sound and free from errors. This is crucial for building trust in AI systems, reducing errors seen in Apple's study. By combining the strengths of both neural networks and symbolic logic, we can create AI that is both intelligent and reliable. Improving planning is also key. AI needs to be able to think strategically and anticipate the consequences of its actions. Future models might simulate possible outcomes, exploring different scenarios and evaluating the potential impact of each decision. Before acting, carefully considering all the available information and making informed choices. Like a chess player thinking ahead. This proactive approach is essential for AI to solve complex problems and achieve its goals effectively. Training must go beyond more data. Simply feeding AI more information isn't enough. It should explicitly teach logic, providing AI with the fundamental principles of reasoning and problem solving. Using synthetic puzzles, carefully designed to challenge AI's reasoning abilities and force it to develop new strategies, and step-by-step curricula. This structured approach to learning helps AI build a solid foundation of knowledge and skills. Evaluation should probe how AI arrives at answers, understanding the reasoning process behind its decisions. Not just whether it's right or wrong, it's about understanding the why behind the what. Transparent, interpretable models are needed so we can see inside the black box of AI and understand how it's making decisions, to spot and fix reasoning flaws. This transparency is essential for building trust and ensuring that AI is used responsibly. The goal is AI that can reason, that can think critically and solve problems in a way that is similar to human intelligence, not just imitate. We want AI that can truly understand the world around it and make informed decisions based on that understanding. Apple's research points the way forward. Their work is helping us to understand the limitations of current AI and to develop new approaches that can overcome those limitations. Building true intelligence will require new ideas, a willingness to challenge conventional wisdom and explore uncharted territory. Not just bigger models, it's about quality, not quantity. It's about developing AI that is not only powerful, but also efficient and sustainable. Apple's study has sparked debate in the AI community, reinforcing concerns that fluency isn't the same as understanding. Experts agree, current models lack world models and planning abilities, as Apple's results make clear. The study's method, using novel out-of-distribution tasks, shows where AIs truly fall short. This has fueled calls for more honest marketing and a shift toward research on reasoning and safety. The conversation isn't about whether AI is useful, but about its real limits. Apple's work is a guidepost, urging a move beyond ever larger models to new architectures. The key lesson: impressive output is not real understanding.
Love exploring the world of technology and AI? Don't forget to like, share, and subscribe to NeoTech-Lens for more insightful and exciting content. Hit the bell icon to stay updated with our latest tech and AI innovations. Your support fuels our journey into the future of technology.